So using exponent laws to evaluate expressions, we'll also do a little bit of simplifying as well. The stuff you need to go forward in grade 12, and then evaluating is good for tomorrow when we start learning fractional exponents. So these are our exponent rules written without words. So this means when you multiply powers with the same base, you keep the base and add the exponents. Okay, so that was a grade 9 rule you use. Divide powers with the same base, you keep the base, subtract the exponents. Raise a base to a negative exponent, it means 1 over that base to the positive exponent. Okay, so this was new in grade 10, our negative exponent rule. And this is an extension of that. If there's a negative exponent in the denominator, bring it up to the numerator and the exponent becomes positive. If you raise a fraction to a negative exponent, you flip the base of the fraction and the exponent becomes positive. Normal quotient to an exponent, you apply the exponent to the top and the bottom. Product to an exponent, you apply the exponent to the both things inside the bracket. And then this is another one from grade 9. If you raise a power to an exponent, you keep the base and multiply the exponents. Okay? So those are all the exponent laws, a summary, I guess, that you learned in grade 9 and in grade 10. Okay? So we're going to use them, pick out which ones we want to use to evaluate, which means find the exact value. So you're not going to answer with decimals, fractions, and closed terms. By applying the appropriate exponent laws to first simplify, so you have to simplify by using an exponent law. So that's going to be your simplify steps. Okay, it's going to be to use the appropriate exponent rules. And then the very last step, go to your calculator and evaluate. Okay? So here's our first question. 10 to the third divided by 10 to the 6th. So you should be keying in on the fact that we're dividing powers with the same base. Everyone see that? Dividing powers with the same base. So the rule says to keep the base the same and subtract the exponents. 3 minus 6 is negative 3. Okay? And then the negative exponent rule says that that's 1 over 10 to the positive 3. And now we do our very last step, is to evaluate. So 1 over, and then I would on my calculator, if I don't know, 10 to the power of 3 is 1,000. Okay, so some people that didn't get to exponents last year or had to learn them kind of on their own. Why does this negative exponent rule work? If you think of this in an expanded way, the top is 10 times 10 times 10. And the bottom is 10 times 10 times 10. You don't have to write this down. Just showing you why it works. So 3 tens multiplying together and 6 tens multiplying together. Yes? So you can divide like factors. So there's only a 1 left on top. And there's 3 tens all multiplying together in the bottom. So that is what 10 to the negative 3 means. It means there's 3 tens multiplying together, but it's in the denominator, not in the numerator. Okay? So that's what you may have missed if you didn't get to exponents, or your teacher didn't get to exponents because of COVID. All right, so similarly, 5 to the negative 2 means there's 2 5s multiplying together, but they're in the denominator. So it means 1 over 5 to the positive 2. Here's your rule. So this sets your rule, and this is your evaluate step. 5 to the power of 2, not 10, be careful, 25, 5 times. -4 to the -2.
No, 1/4
1 over, do I need brackets? Yes, good, because -4 is the base, not 4. Perfect, so that would be our using the rule step, and this would be our evaluate step. So -4 times -4 is positive 16, so the answer is 116. Okay, now we don't have any brackets. What's the difference here? Brackets versus no brackets, what do you think? What's the base? 4 or -4? What is the exponent applying to? Just the 4. Okay, so the negative stays on top, but if there's no number, you'd put a 1, so it makes sense. Over 4 to the power of 2. Okay, so that negative is just like a little -1 multiplying 4 to the -2 out front. Okay. Now we evaluate, so -1 over 16. A fraction to a negative exponent. We have a rule for that. So if you have a fraction to a negative exponent, you can flip the base and the exponent becomes positive. Okay? So there's our rule. So our rule is going to be rewriting this as 3 over 2 to the positive 2. There's our first rule we're using. Now we can use this rule, where we apply the exponent to the numerator and the denominator. And now we can evaluate. So it would be 9 over 4. Next one, again, we have the same base in the numerator and the denominator. It's a divide. So we're dividing powers with the same base. So the rule is going to be keep the base, subtract the exponents. 3 subtract -4. What does that end up being? Hi.
How are you?
Good.
How are you guys?
Yes, to the power of 7. Good. Okay, so 2 to the power of 7, subtracting a negative, we got a positive. Now you're going to go to your calculator and evaluate 2 to the power of 7. What'd you get?
29.
No. 29. Good. 128. Good. Okay. All right. We've gotten a bit more complicated here, so notice that we have the same base in all 3 spots here, okay? So as soon as you see the same base, you're hoping that there's a rule that's going to apply that lets you simplify. So if I simplify, and also a fraction bar means you simplify the top as much as possible, the bottom as much as possible before you divide. Okay, that's how you do the fraction bar, if it's possible. So can I simplify the numerator using any of my exponent rules? Jack says yes. Which rule can I use?
So you add the exponents, so you need 3 to 2.
Good. So keep the base and add the exponents. Is there a rule to use that could simplify the denominator? Yep. Keep the base and multiply the exponents. Okay. Now, I still have the same base in the numerator and the denominator. So I can use an exponent rule again. I can keep the base and subtract the exponents because I'm dividing. So 3 subtract negative 6. 9. And now finally I go to my calculator and do the evaluate step. 3 to the power of 9 is 19,683. Okay, so the way I've got it, if you're looking at it, all the steps in blue are the using a rule, the simplifying steps, and then the final answer is just where I evaluate. Okay? All right, try the next one on your own. Okay. Somebody get the first step for each. That?
So you add the exponents.
Yep.
5 to the second.
Yep. Over 5 to the third. The next simplify step.
You get 5,001.
Good, so you kept the base and subtracted the exponents. Next, 1 over 5 to the positive 1. Do I need to show the positive 1? No, so that's kind of my evaluate step at the same time. It was the simplify and an evaluate because the power was 1. Good. All right, first, showing my rule step for I. Flip and make the exponent positive. Yep. And then apply the exponent to the numerator and the denominator. And then evaluate. So 5 to the power of 3 is 125. 3 to the power of 3 is 27. Everybody good? Excellent. All right, J is a bit different because notice we don't have the same bases, but even if we did, there's no rule for adding powers with the same base. Okay? So we have to figure out each piece separately. Okay, so pretend this is the first piece and this is the second piece and we're adding them. 2 to the negative 1, I can use my negative exponent rule and write it as 1 over 2, the positive 1, which is 1 over 2, plus 3 to the negative 1 can be written as 1 over 3. But that, I can't leave that as the answer because I can add those. How do I add fractions again? Common denominator? Good. So what would my common denominator be here? 6. So 2 times 3 gives me 6. 1 times 3, adjust the numerator. 3 times 2 gives me 6. 1 times 2. And then add the numerators over the common denominators, so 5, 6. And then I set these up beside each other because if you notice, this is what's inside the brackets. Everyone see that? So I can replace 2 to the negative 1 plus 3 to the negative 1 with 5 over 6. And then how do I use a rule to simplify 5 over 6 to the negative 1? Flip them to the positive exponent, which I can just go straight to the answer. I just realized. Power of 1 doesn't change anything. So 6 over 5. All right, I'm going to give you time to try L. Okay, I see lots of people flipping the base. And it turns out we already get a common denominator. It's really lucky. So we get 8 over 2, which is actually 4. 8 divided by 2 is 4. Okay, try then the whole next line. Okay, so what would be your first step for M? Flip it, so what would it be when I flip it, Darius?
Before the power.
Good. You see that? I don't really need 4 over 1 because 4 over 1 is 4. We're really good there. And then 4 to the third is 64. Okay? This should be my evaluate step, actually. All right, next one. Well, 5 squared, I could just evaluate that now, couldn't I? And then minus, but here I have to use a rule. So what rule am I going to use? Flip it, and the exponent becomes positive. Good. So then I'm going to get 25 minus 9, which turns out to be 16. Nice. Okay, anything to say about the first step for this one? Showing a rule. That.
So you want to multiply the exponents?
Yes.
The 3 to the 10.
Yep.
Times 3 to the -6.
Yep.
Over 3 to the 10.
Good.
And then we add the exponents.
So keep the base and add. Yep.
Yeah, which would be the 3 to the 4th.
Yep.
Over 3 second, and then we subtract them, and that just gives you 3 to the second, which is
Good. So that would be using one rule, another rule, keeping the base and adding, another rule, keeping the base and subtracting, and then finally evaluating. So 3 marks just for showing the rules that you use, or showing that you can use the rules. Okay? Rather than just getting a number on your calculator, putting it on the top, a number on your calculator, and putting it on the bottom, and dividing. That's what you want to stay away from. Yep?
You can do that multiple ways, this question multiple ways. I did it a different way, and I still got 9.
What did you teach us?
Okay. I simplified the 3 to the power of 2 right away.
Okay, so you did, yeah. So did you do 9 to the 5th and 9 on the bottom?
No.
So, okay, so you evaluated, which, if you're following the rules of the question, evaluate, find the exact value by applying appropriate exponent laws to first simplify. So you've got to use as many of those rules as you can to simplify, so that you're not evaluating until the very last step, if you can help it. Okay? Okay, so we're on the next step here. What rule could we use for P? Subtract, good, so keep the base, so I'm going to keep the base in brackets as well, and subtract the exponents. Be careful, -7 subtract -9 is actually +2, okay? So careful with that, and then -3 times -3 is +9. Okay, this one often people go astray because they see the same bases and it looks to them like they should be able to keep the base and do something, but how come I can't just keep the base and do something? Right, there's no rule for adding powers to the same base, so you've just got to do each one individually. So 2 to the -1 is 1/2. Plus 2 to the -2 is 1 over 2 squared. Plus 2 to the -3 is 1 over 2 to the power of 3. Okay? So that's going to be 1/2 plus 1/4 plus 1/8. The best I can do, and then I have to be able to add those. So to add fractions, you need a common denominator. And ours is going to be 8, so make everything out of 8. So 2 times 4 is 8, 1 times 4 is 4. 4 times 2 is 8, 1 times 2 is 2. And this one already had 8. So now that you have a common denominator, you can keep the denominator and add the numerators, so you end up getting 7/8. All right, so really the only exponent rules we used was the negative exponent rule. Everything else was just simplifying by adding fractions. All right, R is a tricky one, but one we're getting used to in this year here. Having 4-layer fractions, because that's what we're going to end up with. We're good at those, getting really good at them. So I would look at the numerator. I don't even have the same base. I'm adding. No rule, definitely. So 4 to the negative 2 is 1 over 4 to the positive 2. Plus 3 to the negative 1 is 1/3. Over. Look at the denominator. 3 to the negative 2, 1 over 3 squared. Plus 2 to the negative 3 is 1 over 2 cubed. In the numerator, I have a 16th plus a 1/3. And in the denominator, I have 1/9 plus 1/8. Oh. All right, so what I want to do next is simplify the numerator. So I want to add a 16th and a 1/3. So I need a common denominator in the numerator. So there isn't a smaller one than 48. 16 times 3. Make them both out of 48. So you would have had to multiply 16 by 3 and 3 by 16. And in the bottom, I don't think there's a smaller one than 72. Nine times 8. So that's going to be 8, and that's going to be 9. So now we can simplify the numerator by adding. So that's going to be 19/48 divided by 17/72. And then what's the rule for dividing by a fraction? Multiply by the reciprocal. We'll probably run out of space, so we'll go to the side, multiply the tops together, bottoms together, and reduce. Okay, when I'm deciding how to reduce it, I'm looking at the 72 and the 48, one being on top and one being on the bottom. Because you should be able, 19 and 17 are prime, so they can't be broken down any. So I'm looking for the biggest thing that divides evenly into 72 and 48, and I believe it's 24. It doesn't have both of them. So divide the top by 24 and the bottom by 24 should reduce it as much as possible. So 1368 divided by 24, 57. 816 divided by 24, 34. And that's the best we can do. All right, so that was just numbers, okay? Now we're doing expressions. So apply the exponent rules to simplify each algebraic expression. So it's not going to go down right to a number, it's going to be a simplified algebraic expression. Your final answer can't contain any negative exponents. It's not considered simplified. Anyone remember how you would go about applying exponent rules to something like this? Nobody? Okay. So here's where the same bases come in. X. You see that? Okay. So when you've got 2x to the negative 5, it actually means 2, it actually means 2 times x to the negative 5. Okay, but we don't actually write it like that. We write it as 2x to the negative 5. And same with 7x cubed actually means 7 times x cubed. So when we're multiplying these two terms together, it's actually like multiplying those four things together. So I can multiply the 2 and the 7 and get 14. And I can multiply x to the negative 5 by x cubed using an exponent rule, right? I'm multiplying powers of the same base. So I'm going to keep the base the same and add the exponents. Negative 5 plus 3. Negative 2. But my final answer is not allowed to have a negative exponent.
So you put what you want, if you want a 14x part.
No, it wouldn't, but you're on the right track. What's the exponent on the 14 that I don't see because I don't ever bother writing it down? A positive 1. So that has a positive exponent. Do you agree? So it's fine where it is. So I'll show the longer route of getting there, and then I'll show you what I want your thinking to be. So I could say it's 14 times 1 over x to the positive 2, and then make my 14 out of 1. Multiply the tops together, and multiply the bottoms together. And that should make sense to everybody. Okay, that's definitely a route you can take. But when you end up getting 4-layer fractions, that's a stressful route to take. Okay, because you're going to keep making things 1 over all the time. So another route to go is to say anything with a positive exponent can stay in the numerator. Anything with a negative exponent has to move to the denominator so the exponent can become positive by using the 1 over rule. Okay? So if it's got a positive exponent, it stays in the numerator. If it's got a negative exponent and everything's multiplying, we're going to move to the denominator so the exponent can become positive. All right. Next one. Similar thinking here as this. So I can treat the coefficients, the negative 15 and the 3, and divide those, because this is a divide sign, and get negative 5. And I can divide the powers of x by keeping the base and subtracting the exponents. 11 minus 17 is negative 6. And then I'm going to check. What is the exponent on negative 5, or on 5? Positive 1. So the negative 5 can stay in the numerator. What's the exponent on x? Negative 6. So it's going to move to the denominator, and the exponent becomes positive.
What if the exponent was positive?
Then the answer would just be negative 5x to the 6. Okay? All right. Negative 45, a to the 5th b cubed c squared divided by 9a cubed b squared c squared. So we start off with the coefficients. Negative 45 divided by 9. Negative 5. A to the 5th divided by a cubed. A to the 2nd. B cubed divided by b squared. B to the 1, good. C squared divided by c squared. C to the 0 where they cancel out. Do you see that? Okay. They're exactly the same. So then I ask myself, what's the exponent on the 5? 1, A positive 2, B 1, so everything stays where it is, because they all have positive exponents. Which was Molly's question that we just answered, right? They all have positive exponents, they all stay in the numerator. Okay, x to the 7th to the negative 5. So the first exponent rule we can use here. Yes, so keep the base and multiply the exponents. Second exponent rule that I could use. The negative fraction, so 1 over x to the positive 35. Good. Okay, I'm going to put a little star beside this one. Try it first. And if you make the mistake, hopefully you will remember. Okay, who thinks they've got the first step for that? How did you get the 4?
Because the power of 2 on the outside applies to the 2.
Awesome. So the middle step that Darius did in his head, which you don't need to write down, you can do it in your head, is 2 to the power of 2, so that 2 applies to the little 1 that's invisible there. So 2 to the 1 times 2, x to the 3 times 2. Okay? And then that's 4x to the 6. The common mistake is to just put 2x to the 6 and not apply the additive exponent to the 2 as well. Okay? It's really common. All right, this one's when we're not just doing numbers, but we're doing all variables. I don't necessarily use the flip the fraction, change the exponent, because I'm just going to multiply all the exponents anyways, and some will turn out to be positive and some will turn out to be negative when I multiply. So I can apply the negative 2 by multiplying it to the negative 3, multiplying it to the positive 4, and multiplying it to the negative 5. So apply the exponent of negative 2 to every single thing in the bracket by multiplying. Now I would ask myself, the exponent on this one is positive, so it's fine where it is. Exponent on this one's negative, it's not okay where it is. Exponent on this one is positive, it's okay where it is. Everyone good with that thinking? As long as you've got a positive exponent, you're fine. So, my last step here, okay, so now the only thing left in the numerator is going to be x to the 6th, and in the denominator, I'm going to have not only my z to the 10th, but y to the positive 8. So I moved it to the denominator, and the exponent became positive. Okay? All right, G. So you're going to start off with the numerator. So So multiply the coefficients on the numerator. So you're going to start off doing negative 12 times 45. Negative 540. Now you're going to multiply the powers of x. So that's going to give me x to the power of 6. Good. Did anyone put 8 accidentally? No? Okay. Oh, you did? Okay. So when the x is actually written in 2 spots, you're either going to keep the base and add or keep the base and subtract. Okay? And because we're multiplying, we add.
Yeah.
Whereas up here, see how the x was only written once and we had a power to an exponent? That's when you multiply the exponents. Okay? So the next thing we're going to do is multiply the powers of y. So to multiply the powers of y, I again keep the base and add the exponents. So that's going to give me y to the 1. Okay? You don't need to show it, or you can. Over 36, x to the 9th, y to the negative 6. So your next step is going to be to divide. Okay, so you divided the coefficients and got negative 15, x to the negative 3, good, so keep the base and subtract the exponents. Y to the 7, good, positive 7. Because 1 subtract negative 6 is positive 7. Okay. Now you go and analyze. I know the exponent on 15 is 1, so it's fine where it is. So the negative 15 stays in the numerator. So does the y to the positive 7. But the x to the negative 3 needs to move to the denominator so the exponent can become positive 3. So that would be your final answer with all positive exponents. This is also the answer, but it's not simplified. It's not considered simplified if it still has a negative exponent. Okay. All right. H is a tricky one. We can flip and change the exponent, but the reason I would be more likely to flip in this case and not in this case is because this one has no coefficients. There's no plain numbers to apply the exponent to. Okay? There's just variables. So I might be more inclined to flip this, but remember when you flip it, all you're doing is changing the numerator and denominator. You don't change any of the exponents. Okay, so there's still that exponent of negative 2 on x, and that's a common misconception or misunderstanding. This exponent changes to positive 3. So now I can apply that exponent to the numerator and to the denominators. That would be my next exponent rule that I'm using. But I have to remember, and maybe it would help you to write it like this first, with the brackets, that 3 is applying to everything inside the bracket, not just the variable. Thank you very much. So, this power of 3 applies to the coefficient. So 3 to the power of 3 is 27, not 9, which is another common one, but that's just an accident really, but you're still thinking you're applying it. Y to the 3 times 3, which is 9. 5 to the power of 3. Yep. Yes. X to the negative 6. So remember, anything with a positive exponent is fine where it is. Fine, fine, fine. That one's not fine. X has a exponent of -6. So how can I rewrite this so all the exponents are positive? Way back at the beginning. If you have a negative exponent in the denominator, if you move it up to the numerator, the exponent becomes positive. So we can apply that here. So I can write this as 27x to the 6, y to the 9 over 125. Okay? So I just moved this up to the numerator so the exponent can become positive using that rule. Okay, 5x to the -2 all to the -2. All right, I'll give you a minute to think on that one. Okay, does anyone have a step here?
You would, make it, maybe flip it, so you have 1/5 instead of x, -2, and then you have 2 on the side.
I think I know what you're saying.
If you have 1.
I'm going to show this middle step here, but then I'm going to do what you said. Okay, so 5. So first the -2 applies to the 1 that's you don't show on the 5, and then also applies here, which gives you +4. Do you see that? And then Darius said 5 to the -2 is 1 over 5 squared. Okay, so same thing as doing this. Everybody good there? I can't leave it where it is because it's negative. I also can't evaluate it till I have a positive exponent. And because 5 squared is actually something we can figure out, unlike x to the 4th, we can make that 25. Okay? All right, before I hand out the practice, I just want to use whiteboards. Oops, I didn't. I just want to use whiteboards to go over some more that have letters in them. And then we'll do the practice. You need your marker, eraser, whiteboard. We won't go fast, Mia. It's Monday. Okay, there's our first one. We want to simplify as much as possible. 2a cubed to the -3. Simplify as much as possible. So I see 2 schools of thought, and I want you to see that they both get you to the same place. Okay, so Jack, tell me what you did. What was your first one?
2 to the -3, a to the 9.
Close?
-9.
Yeah.
Yeah.
Does everyone see that? The way Jack got that. So he applied the exponent to each piece in the bracket. Okay? And then he decided that they both had negative exponents. So he's moving them to the denominator. What's going to be left in the numerator?
1.
Good. Okay, so now they have positive exponents, but is that the final answer? Am I allowed to leave that? No, it's close, but I can figure out 2 cubed is 8, 8 to the 9. Okay, so that's what I would do, but there's another way to do it as well. So Katie's thought was?
1 bracket 3
Good, okay. You see what her thinking was? So I have something to a negative exponent, so I'm using my negative exponent rule and making it 1 over that same thing to the positive exponent. Okay? And then her next step would be to apply the 3 to both things inside the brackets. And notice how you got the exact same answer, no matter which train of thought you were using. Okay? All right, let's try another one, kind of similar. Yeah. Well, all right, who wants to give me their first step for this one? Darius.
I had a 1 over 4 x to the power of negative 2 bracket, the other side of the bracket, and then plus.
Okay, and then what did you do?
And then after that, I substituted in.
Yep, or you applied the exponent.
Apply it, yeah, so then I would initiate
4 to the third.
the power of negative 6.
Good, and then what did you do?
And that could be x to the power of negative 6 on top.
To make it x to the 6, good.
And then I'll use that.
Nice. Okay, so that's one way to do it. Who did it the other way? And then what was your thinking? Jess?
My first step was 4 to the power of negative 3.
Yep.
And x to the power of 6.
Yep.
And then I would put the 4 to the power of negative 3 in the denominator, so it's just to the power of 3.
Perfect.
And then the last step would be exact same. It's awesome.
Perfect. Okay, so we got the same answer both ways. Okay? Same answer both ways. Good. All right, let's do one, okay, different. So how about this? Negative 7x to the 4th times 5x to the negative 11. Need a marker, please? Down to the last one, last one. 3 quadmasters. Who thinks we got a first step for this one? Darius?
I got negative 5.
Yep.
And x to the power of negative 7.
Good. How many people got that? The first step. Excellent. All right. And how did you finish it off, Darius?
I left negative 7.
Very good. And how come you left the negative 35 in the numerator? Exponents of positive 1. Yes? Okay. Now we'll try a dividing one. Well, it's fine. Okay, so 54 x to the 6, y to the 3rd, z squared over 6 x to the 5th, y to the 5th, z to the 5th. Okay, volunteer to tell me their first step. Yeah.
So I got 9.
Yeah.
And then x.
Yeah.
Y to the power of negative 2.
Yeah.
And z to the power of negative 3.
Good. How many people got that for their first step? Well, this is very good. Okay, and your next step, Darius.
I got 9 to the x in the numerator.
Yep.
So y and z to the z.
Y squared z cubed in the denominator. Yes? Excellent. Okay. You're dividing one. Negative 36 a to the 4th over 12 a to the 7th. First step. Yep.
I got negative 3 and then 8 to the power of negative 2.
Perfect. And then last step.
Negative 3 on top, 8 to the power of 6.
Good. Okay, our last one, we'll do a brackets one. First step. Okay.
I flip it.
Okay.
3 on top of the 4 on
I would do that. I know I have a choice, but I would do that in this case because I see no negative exponents anywhere there inside. So I would definitely flip so that everything's positive. All the exponents are positive. Okay, and then with your next step.
So negative to the power of 3 1 and you have 27 to the y to the power of 3.
Yep.
And so that would be x, 8x to the power of 1.
Good. And if you wanted to put middle steps in of 3 cubed and 2 cubed, that's fine. But how many people ended up with that? Any questions about that? If you're not sure, leave it on your whiteboard and I'll come around and help you. So